This will allow the user to walk around freely and explore the design. We will discuss 2 different control setups and also show you an example of loading a different character. Finally, we'll add an additional view from the top as a minimap. In the first video of this section, adding a first-person character, we'll explain how to add a first-person character to walk around. Since a first-person character is fairly complex to set up and involves scripting, Unity provides a ready-to-use navigation system. This requires the import of a package of assets that Unity provides from the Asset Store, an online integrated store for Unity assets. We'll use the sample assets package from Unity, which contains a prefab you can drag directly into your scene and configure with parameters. Prefabs are game objects that are stored as asset files and which can be reused in all scenes of your project. When you change a prefab, all copies will automatically update. We already showed you how to load a model from SketchUp and Archicad. Now open the Asset Store tab, menu, and look for sample assets. At the time of recording the video, they were still in beta, but are meant to replace the default standard assets that might still be installed with Unity at the moment you watch this course. After you have created a free account in the Asset Store, you can download this 200 MB package for free. When the download finishes, Unity will show the contents of this package file, which is an archive with assets, scripts, models, and even an animated and textured 3D character. For convenience and to ensure that nothing is missing, select All and press Import to load the whole package. After quite a few moments, the assets are loaded into the project. Navigate inside the Project tab and fold out the Sample Assets, Characters, First-Person Character folder. Select the First-Person Character prefab in the Prefab folder and drag it onto the Scene view to place an instance in the scene. Also, add a plain game object, which acts as our ground plane. Reposition it, set big enough scale to make sure that we encompass quite some place. This will be our ground. Select the first-person character and move it upward. This will be the beginning position of our character. Beware that if you come from a CAD or BIM background, that Unity uses the green Y-axis as the vertical axis instead of the Z-axis, which is displayed in blue. Navigating a first-person character requires the use of the mouse to aim in a particular direction and the arrow keys or the WASD to move. However, if you don't use a QWERTY keyboard like I do, this is not a very comfortable setup element. Luckily, Unity also supports an attached gamepad or joystick, which usually can be used directly. You might see some warnings in the console that there are 2 audio listeners. This is because the default camera and an additional camera that has been included in the first-person character are both listening to the sounds that are played. Also, the main camera is hiding the display of the first-person camera, so we remove the main camera. If you press play now, warnings should be gone. The first-person character now you can walk around, use the mouse to display the certain direction, and use the arrow keys or the WASD keys to move back. We can further explore some of the properties for the first-person character control if you select it in the Hierarchy tab and look at the Inspect. First-person character component script defines the speed of walking and running and the jump power, how strong you can jump. A simple mouse rotator is responsible for the reaction on moving the mouse around. First-person head bob script adds stepping sounds and a bouncy up and down movement while walking. You can disable this component if these movements disturb you or your. This object uses the physics engine, so it also needs a rigid body and capsule collider component. The mesh renderer itself is turned off, so you cannot see the capsule that represents yourself. You might have noticed that we can safely walk around on the ground plane, but we can still pass through the walls of our house. This is something that we'll solve in the next video. So, within this video, we learned how to walk around our project, use the predefined first-person character, provided as part of an asset store package from Unity. That was not too hard, was it? To video 2.2, preventing running through walls. In the previous video, we noticed that we could walk right through walls. We are also not able to step onto the stairs of our model. In this video, we will look at colliders. This is geometry that is used to check if objects overlap, pass through each other. This video will add colliders to our project and also briefly discuss other possible colliders. In game engines, geometry is not automatically set up to collide, prevent extensive collision calculations. By only adding colliders where needed, we can limit these calculations. Let's check where we have arrived after our last video. In the Project tab, look at our model. Select our model and look at the inspector to adjust the importer settings. We have to activate Generate Colliders and press Apply. This generates a mesh collider for all the meshes in the model. You can see that every object that has a mesh now also has a mesh collider component. We can check that it works by pressing play now and walk through our building. Now we will automatically stop when we bump against the wall. So, in most cases, we want our architectural models to have colliders for every mesh, and this is easily set by the importer. However, there are cases where this is overkill. If you have very detailed geometry, such as plants or chairs or even doorknobs, they might slow down Unity considerably. In some cases, our controller might even get stuck. It is possible to be more selective and disable certain colliders. If you have a model with closed doors, or you have a wall where you want to pass through, we can disable their collider, which would allow us to walk through them again. While this is not very realistic, it solves at least a problem in initial projects when you are not able to enter a door. So what about regular Unity geometric objects, such as cube, cylinder or sphere? They all have a default collider applied. Add a few cubes, maybe a sphere, if you press play now, you can see that the sphere will prevent us from walking through. Same with the cube. If you look at the properties of these objects, you see that the sphere has a sphere collider and the cube has a box collider. Each game object can only have one collider component of each type applied, but you can combine a box collider and a sphere collider for more control over their collisions. Collision detection takes quite some resources and slows down the scene. You can replace complex colliders in many cases with a basic box or capsule collider. You can remove the mesh collider or disable it in the FBX importer settings for a model. Convex colliders, such as box, cylinder, or sphere, are easy to calculate. Concave ones, such as the mesh collider, are more demanding and should be disabled or replaced where possible. You can create a compound collider by combining different collider types in one object or adding multiple objects together, each with their own collider. Since collider geometry is invisible, it poses no visual problems, yet still ensures that we steer where the user can walk. Many games apply invisible walls to prevent users from stepping outside an allowed area. This is easily done in Unity by adding a cube game object and disabling the mesh renderer component. The attached box collider will still prevent objects from passing through. This concludes our second video on navigating, where we added colliders to our project and also discussed how and when to use them. Remember, you can disable or even replace colliders to fine-tune the game performance. The next video will discuss an alternative character setup. In the third video on navigation, we will talk about the third-person character, which is an alternative character setup where the player watches a 3D animated character, usually from behind and slightly above. In this video, we'll add a third-person character and properly set it up. In architectural visualization, it is often easier for users to navigate a third-person character using arrow keys. People who are not accustomed to 3D games might have trouble with navigating a first-person character around, although that allows for more control over the direction in which you look. Since it is even more complex to prepare a fully animated 3D character, we'll use pre-created characters. Luckily for us, the sample assets package from Unity we loaded in a previous video also includes a usable setup. First, remove the first-person character from our scene and drag the third-person character from the sample assets prefabs into our scene. If we would press play right now, we would get several setup problems. And we find no main camera. Luckily, this is straightforward to solve. Within the sample assets, there are a few different camera prefabs. We will drag the multi-purpose camera rig into the scene. In addition, we'll also add a basic directional light to remove the dark lighting we get in the project. When we press play now, this specialized camera rig by default will automatically follow our main character around, wherever he goes, using the AutoCam script component. There is also a protect camera from wall clip script component, which prevents this camera to fly through walls. This is very handy, especially when we walk inside a building. Try to walk around a bit. Press Shift to have the character walk instead of run, space to make him jump. With this setup, we cannot really steer where we are looking at. If you want to allow the user to use the mouse to look in all possible directions, remove the multipurpose camera rig from the scene and try the free look camera rig instead. Now you can pivot around the character with the mouse and still walk freely with the same cursor keys as before. Both setups provide a complete animated character, set up to be steered by the cursor or alternatively by gamepad. The difference here is mainly in the camera follow behavior. The third-person character component defines the movements, where the third-person user control allows you to define how he moves relative to the camera. You can also set if the character walks or runs by default. So there we are, a fully animated 3D character which we can steer around our project easily. Of course, the internal behavior and scripts are provided from the sample assets package. In this video, we replaced the first-person character with the third-person character. It took a small effort to refine the camera setup, but in the end, we have a chance to experiment with the two most common navigation schemes. The actual scripts that do the hard work are a bit too complex at this point. The main setup is easy to reuse. Our next video will take a look at switching to a more regular character, better adapted to architectural visualization. Welcome to video 2.4, loading a different 3D character. While the model from the previous video is usable, it is probably not the best style of character to use in an architectural visualization. In this video, we show you how you can download an alternative character with animations from the asset store. While it is possible to model, texture, rig and animate a 3D character, this takes an enormous amount of time. In architectural visualization, it is common to use prepared assets and focus on the design of the building rather than the details of the model. Open the asset store, and when looking for a usable character, we landed on content for Mixamo, which specializes in 3D characters and associated motions. They have a few basic characters available without cost, but the animations have to be bought separately. We decide for the popular Mixamo assets as their characters and animations are all compatible. When looking at other characters and animations, they might not directly work with each other or require additional customization using the integrated Mechanim animation system. After looking around, we settled for man's everyday motions, which is a male character with 10 different basic motions. It costs almost €30, which still is a fair price. When you buy the packet, you can import it directly into Unity, just like any other package. This package includes an example scene, which illustrates a character with animations and a controller scheme. This setup uses a particular method of animation control called root motion, where the movement of the character is directly derived from the actual motions. This has this distinct advantage that the motion is more natural and the feet don't slip. Let's go back to our regular scene and remove the third-person character from last video. Drag the Justin prefab into the scene and position him in a suitable place. You can see that several animations have already been applied, and there is a root motion computer and a root motion character control script, which defines the keyboard actions alongside a regular character controller component. If you press play now, the character starts moving. This setup uses WAD to move forward or rotate, and you can hold Shift to have the character run. Arrows are not recognized in this example script, alas, and also the backward movement is missing. There are a few warnings about finding certain components, but the script does find them automatically at run. Beware that the camera is not following the character automatically, like we had in the previous video. Here we illustrate a quick and rough method without resorting to scripting at all. Add a new camera, increase the depth so we are sure that this is the camera we see above the others, and drag it just on top of Justin to make it a child of the character. A child follows the movements of its parents automatically. Now we can position the camera relative to his parent. Set the X to 0, Y to 2, and the Z to -2. When Justin walks, this camera stays fixed about 2 meters behind him and slightly above his head. While this is a very crude setup, it is a quick fix without requiring any scripts at all. You see the same warning about audio listeners. However, when you use scripting, you can make it smoother by using interpolation to give it a slight delayed movement, just like we had third-person character example setup. Let's remove this camera and reuse the free look camera rig. In this case, we get an error. The variable target of FreeLookCam has not been assigned. If you look at the FreeLookCam, the target variable is where the camera would look at. So, select FreeLookCam and drag Justin as a target for the FreeLook camera. If we press play now, the last errors are gone. The camera is able to follow Justin around the same way as we had with the previous video. We can also apply the multi-purpose camera rig instead of the FreeLook camera rig, as long as you ensure that Justin is set as a target for the AutoCam script. And now the camera follows Justin around when walking. In this video, we replaced the default third-person character with a more suitable one that was bought from the asset store. This did provide a different setup, so we had to do some additional work to get the camera correctly follow the character. But this is a very usable result and with a more suitable character. Our next video will use a similar trick to add a top camera and a small corner viewport above our main view. Welcome to video 2.5, adding a minimap. In game navigation, you are often helped by a radar view or a minimap. This displays a scene as seen from above and is placed above the main screen. In this video, we'll use a second camera and configure it without scripting to add a second display above our main camera. While not the most elaborate setup, this is easy to do and is directly usable. You can start from the scene from one of the previous videos. The process is the same in each case. First, create a new camera. This adds a new camera in the project, which is displayed above our main camera. Remove or disable its audio listener. At this point, the game window you see in the camera preview shows part of the scene and the blue background color. If you set the clear flags to depth only, the background becomes transparent. This camera blocks the view of the other camera, so we have to adjust its viewport rectangle in the camera component properties. We chose x equals to 0.74, y to 0.01, and the width and height both set to 0.25. This places the camera in the bottom right corner, but you can adjust this to your liking. Now adjust its projection by switching it to an orthographic projection, as this makes more sense for a camera top view. The next step is changing the orientation so the camera looks down from the top of the project. Set rotation X to 90 degrees. We can also move it upwards by setting the Y position 2 meters. Now it depends on what you want to do. If you simply need an overview, adjust the size parameter of the camera to make it large enough to see the whole scene from above. In this case, the camera stays fixed in its place. We can then attach a large sphere to our character as a child and place it above the roof of our project. Ensure that our Minimap camera is placed high enough so it can see the sphere. Now this sphere will be shown as an indicator of our character. A more advanced trick is using layers. This can be used to toggle the visibility of objects for different cameras. Go to the layer dialog. We add 2 new layers. Let's call them Minimap and non-Minimap. Now we can set the layer for the sphere to the Minimap layer. The ground plane, which is part of our model geometry, is set to the non-Minimap layer. Right now this doesn't seem to have any influence, but the moment we adjust our camera, we can set them to ignore particular layers. Our Minimap camera will ignore the not Minimap layer. Our current main camera, in this case hidden inside the multipurpose camera rig, can be set to ignore the Minimap layer, so the sphere is not visible for the character. Now the plane is hidden from the Minimap and the sphere is hidden from the main view. If you want to follow the character with the camera, you could attach the camera as a child to him, so it heads all movements and rotations. However, for more complex setups, we will need some scripts. In this video, we illustrated a very simple setup, but for more elaborate setups, such as displaying lines or icons or inheriting particular movements but not rotations, you definitely need to write a script. This is the last video of the section on navigation. The next section, we will apply shaders and textures to our setup.